Good afternoon, everyone. How are we doing today? And I'll continue with section 3.1. Maybe try to move into 3.2 if I'm able. We'll see. So let's look at this problem. So we have 4x plus 5y equals 7, and 6x minus y equals 8. And I'm actually wanting to. There's two ways I can solve this, and I'd like to look at both ways. The easier thing to do on this problem, to be honest with you, is to eliminate the y's. And let's do that. And notice I have minus y here, and that makes 5y vulnerable. I could multiply this second equation by 5, and that's going to cause a negative 5y. So let me do that. And but you got to multiply the whole thing by 5. And I'll line it up. So create a, but I'm going to do it the other way too. Now we don't always get a nice get up like this or set up, but enjoy it while it's there. Now, when you distribute the 5, you need to drop the parentheses. There's no point if you don't drop the parentheses. So 30x minus 5y equals what? 5 times 8 is 40. Yeah, looks good. So, yeah, no, actually that's good. And now, what I want to do, I have this. Let me copy it, paste it, and all that good stuff. And create a little nice spacing there. So I'm going to put a parenthesis, and let me get inside the command. Put a little parenthesis, and I guess that's good. Come on now. Okay, that's good. And I'm adding x's to x's, y's to y's, and pure numbers to pure numbers. Okay. Now, I cooked this problem up myself. I can't promise that this is going to come out to be a pure digit. It probably will not, but if we get lucky, yeah, maybe. And but anyway, well, it kind of did a line completion there. Now, 4x plus 30x is 34x, and equals, now 7 plus 40 is 47, like that. Now we get 34x equals 47. Now from the last video, we saw that we just divide both sides by whatever term is hugging your x. It's 34 who we divide by. So let's divide by 34. And we get x equals, if we divide both sides by 34, I get 47 over 34. And technically I need to check and see if I can reduce this. But ultimately it will not reduce. 47 is a prime number, in fact. So this will not reduce. But I do need to check. So we have our x. Now, finding our y is easy. Once you have your x, you just plug x back in and find y. So I have, we could use either one of the originals. I'm going to pick on this one right here, the second one. You could use the first one just as well. But I'm going to use the second one because I'm in the mood. So we have 6x minus y equals 8. But hey, we know who, well, no, we don't know who y is, do we? We know who x is. We know who x is 47 divide 34. The fraction 47 over 34. Okay. Well, that's all well and good. So we find y from here is what we're doing. And if I explain the process, I'm pitting negative y against 5y. Okay. And that's what we just did. And to solve, to find x, to cancel y and find x. And we did that. And then we find y from here by plugging the x value in, or by plugging in the x value. Okay, so I'll plug in the x value, and I get that. Well, shucks, I'll be good. Now, if I Control C, and now, guys, this may get what I call a little bit messy. You could use your calculator here, but oh well. I know about reducing fractions. 6 and 34, 2 goes into 6 3 times, right? 2 goes into 34 17 times, right? And I don't really want to get lost in the sea and the ocean of arithmetic. Yeah, this could get yucky. Now, by the laws of arithmetic, 3 is really, who is 3? 3 is really 3 over 1, right? And let me hit the right spacer. And, the space bar. No, it's neither left nor right, it's just the space bar. Now let me hit the enter key to go down. Now 3 times 47 is 141. Wait, no. Yeah, it's 141. Okay. I didn't want to say anything foolish. Now gotta get rid of that. Now 1 times 17 is 17. And I can get rid of these parentheses are now kind of foolish. So 141 over 17. Now I'm going to do what I call the Benedict Arnold. If any of you all are history people. Now, negative y, if you jump the equal sign, you change negativity. I want pure's on one side, y's on the other. So I want neg y to come over here as plus y. I want pure 8 to come over here as minus 8. Adding to both sides and subtracting from both sides is correct, but it gets irritating. I like to just Benedict Arnold. Now, if you bring out your calculator, yeah, you could 17 times 8 at your own risk. Well, 8 is 8. Well, who is 8 in the first place? 8 over 1. And, well, we have 8 over 1. Now, we need common denominator. 1 times 17 here to get is 17, right? That's the whole point. We want 17. Now, 8 times 7, but the price you got to pay is you have to multiply 8 by 17 up there. And that looks like a 136, right? If you do longhand multiply, like you did in the 5th grade or whatever grade that was. So, 136. Well, now I'll resist all temptation to take the news. So insert equation. So that's 5 over, no, we subtract the numerators. That's by the laws of arithmetic. That's going to be, we can weld. Come on now. We don't mess with 17, but we do 141 minus 136 over 17 equals y. Well, by symmetry of equality, by logic, really, if this equals that, that equals this. So wait. Well, let me finish what I started. Sorry. So that's 5 over 17 equals y. I didn't mean to erase it. I didn't mean to do that. Come on now. But by logic, if this equals that, that equals this. Well, so if that equals y, y equals that. 5 over 17. That's just by pure logic. Common sense logic. Okay. I guess we call that symmetry of equality or whatever. So I'll hit Control S and we'll call this guy 3.1 continued. And it looks good. Now, so we have that and have 5 over 17. And if we plug these back in, have 5 over 17 for y, that one, and now 5 over 17 can be thought of as 10 over 34. Now x is 47 over 34. Ew. Well, let's see. If if I go to, if I plug it in, I won't lie to you, I'm gonna get my cell phone. I'm not gonna lie and say I'm right when I'm not, okay? I don't think I've made any boo-boos here. This leaves you feeling, I made these numbers up and that made them a little pesky. Well, let's see, 6 times 47 is, well, let's see, I'll use Google. 6 times 47 is 282. So it's 282, and then minus y. So it's 282 over 34 minus y, but in terms of 34, y is 10 over 34. So it's 272 over 34. And 272 over 34 is 8. That's it. It worked. You can plug these back in. They do work. So now, guys, the last thing I check these again in my cell phone, Google. I plug these into Google and they do work. And now, kind of the moral of the story, though, is, well, let me go to Google. I don't think I've got anything FERPA related up. I hope not. I was just getting the institution code there, so that shouldn't be FERPA related. 6 times 47 over 34 minus y in terms of, and y is 10 over 34, but that's just 5/17. There's 8. Now, WebAssign, assignment previewer. Now, WebAssign gives you all these special cases. I wanted to get down to the punch and give you something that was real general. Now, I need to give you the ordered pair. Remember, guys, X always comes first, even if it wasn't the thing that you found first. Well, in this case, you know, it was. But that won't always be true. But X, let's see, now working memory is not working. So 47 over 34, and Y, so X is 47 over 34, and positive, and Y is positive 5 over 17. Now you want to, guys, at the end of the day, you want these reduced. The only reason I kicked back up to 34 for Y a minute ago was to check my answer. You don't want to, you know, when you write the final answer, you want 5/17 for Y. Now the X coordinate, remember, we could not reduce it, right? 47 over 34 just didn't agree, you know, to reduce it. I couldn't reduce it. You know, 10 over 34, it did reduce. But, well, actually, we didn't even get 10 over 34 in the first place. We got the real McCoy. 5 over 17 doesn't reduce, by the way. So you do want to check, but you can tell right away, 5 over 17, no way, right? That's not going to reduce. I should have pointed that out earlier. Well, so here's my ordered pair solution, and it does work. It checks out, and all good. So, but let me do another one. I want to generalize, and this should cover 100 problems, and I wouldn't have to be so piece by piece about things like they are. And I like WebAssign, but I don't love everything about it, I guess is what I'm saying. Let me consider, what if I want to do something that might force the issue a little bit? What if I did like 6x minus 5y equals 2 or something? Now, I want to do one where I can't necessarily wiggle out of. One that, you know, I might not necessarily can just weasel and get out of. So 6x minus 5y equals 2. And let me insert equation, and let me do 8x minus, now I don't want to use y as a scapegoat this time. I don't want y to be easy to wiggle out of. Not anymore. 8x minus 9y equals I'll just say, for argument's sake, I just need something to go over there. Let's just say 7. Just something to go over there. Now, guys, and I single space these this time, and it'd probably be prettier if I double spaced them. Okay, so let me do this. Control C. I like to have my problem statement. So solution. It'd been nice if I'd have done that in the last problem, but oh well. Now, so what I'm going to do. Now, 8 and 6 have some kinship. 5 and 9 have absolutely no kinship at all. Now, 5 and 9, the least common multiple is just going to be 5 times 9. 6 and so I would need 45y if I eliminated y. Now, x, let's look at x. Let's back up and look at x. Let's slow down, back up, and look at x. Now, 6 and 8, I could do 6 times 8 is 48, and that would be allowable. That would be permissible. But now there's a better, smaller number. The 48 is a common multiple, but it's not the least of the common. Actually, the least common would be 24. If you use your fingers and counted by 8s, you would do 8. 8 itself is not a multiple of 6. And then 8 times 2 is 16, still not. But then 8 times 3 is 24. There you go. So what we need to do is multiply by 3 to get that 24. That's how you do it. And you need 6. We want 6 to turn into 24. Well, we want to multiply 6 by the thing it needs to be to become 24. Obviously, 6 is not 24, but we want to multiply. We want to product it into 20 to make it 24. Okay. You know, they're obviously different numbers. But anyway. Now, so, and 6 times 4 will do the trick and give us 24. Likewise, 8 times 3 is 24. But the price you got to pay is you have to multiply the whole top equation by 4 on account of the 6 hitting the 4. And likewise, the 3 hits the 8, but it's got to hit everybody else as well. And that's the price you had to pay. The distributive price. Okay, now distribute through. Everybody gets hit by 4. Just keep that in the back of your short-term memory. 24, 20. Now, guys, don't have a short-term memory glitch here. Try not to. You get 8 there. Now, short-term memory. Now, I would start back here just so you don't have a short-term memory pitfall. 21. 3 times 9 is 27. 3 times 8, that's why we came to the party, right? 24. If you go right to left, I find that when I do, my short-term memory doesn't betray me as much. And then you want to get rid of that 3 because he's exhausted, because he's already been distributed through. He's done. And the parentheses are done. Well, or at least those parentheses are done. You know, we may do other parentheses later, but that's a different story altogether. Now, Control C, and then now eliminate the 24s. Well, so we'll eliminate the 24s. And, well, what about it? Let's do it. Now, since they have the and we'll subtract since they have the same sign. Since they have the same sign, we would have added. We would have added if they would have had. If they, this thing is slow, would have had opposite signs. That's not the case here. Such is not the case here. Okay, so we subtract because 24 is subtract since who is they? The coefficients. Since the 24 coefficients. I hate the word they. So since the 24 coefficients have the same, and what kind of sign? Positive one, right? Since they have the same positive sign, we subtract. We want to eliminate them. We don't want them to. We don't want to make 48. We want to make 0, right? We want bye-bye. We don't want reinforce. We don't want a whole lot of X. We want a whole lot of bye-bye, right? So we won't see you later. We won't get going. Now, you may rightfully ask, well, Jason, could you switch the ordering? and subtract the top from the bottom. Absolutely. I just don't feel like it right now. And that's the only reason. I just feel I'm just in the mood to do it this way. Now, Word completed the line for me. That's a little weird, but it's okay. I don't feel like... we'll just let this be. Now, guys, be careful. If you have a minus and a minus that was already in here, it becomes plus a positive. So really, you got neg 20 plus 27 positive. That's actually positive 7y. And you could think of that as 27 minus 20. Or, well, more specifically, 27y minus 20y. So that's 7y. And I'm good down here, but you care if I use the pretty editor? Let me use the pretty editor. So that's pretty editor 7y equals. Now we got positive 8 minus ordinary 21. Now that is neg 13. Well, I'd have thought I could. That's okay. But anyway, now let's see. Well, then again, no, that would have been harder than I thought. So we got 7y equals neg 13. And then divide, well, by algebra 1, we just divide both sides by the coefficient hugging your y term, multiplicatively hugging. So we divide both sides by 7. And that's going to be y equals neg 13 sevenths. Let me go down, Control V. Yeah, so divide by both sides by 7. And I'm going to just be pretty blunt here. That's negative. That's going to be negative 13 sevenths. So that's not all that exciting. So that's our y. Now again, so we plug this y value. We plug this y value back into either of the original equations, or either one of the original equations. Well, guys, I don't know. It just whichever one you're in the mood for. My mood, I guess. Which one of these better suits the mood? It's negative 13 over 7. The 7 is on the bottom. Which is more utilitarian? Neither one. Let me just use the top guy. The bottom guy would have been fine. Either way, you just pick one. I'm literally just going with the mood I'm in. So Control V. Now I plug that in for y. So neg 13 sevenths gets plugged in. You'll need the parenthesis because you're using a number now, right? It's sort of when variable we don't, number we do, and a lot of people find that weird, but it's just the table manners of algebra, right? You use number when you we use parentheses when you put the number in. It just is what it is. It's kind of like wearing I guess a tuxedo to a prom. It's one of those things. You put parentheses around the number, I guess. Now, Control C, Control V. Now, guys, you see, but now I'm minusing a negative, right? So we can that's plus a positive. So we can get rid of both of these negatives if it will be so. Yep. Well, so we get plus a positive. So, yeah. So we got plus a positive there. And because I'm minusing a negative, and indeed, if you want me to do another inline here, and I might ought to, what's really happening here, to be honest with y'all, is I'm minusing. If I want to pull that negative out and sort of take the wrath of the negative out on the 5 there, I can, right? And make the 13 sevenths positive. So yeah. And really, if I want to spare and what I can do, if you really want me to be maybe almost too geeky and spending too much time on this, if you want me to spare the 5, I can take out the ultimate default, the negative 1. Like that. But do you really need to devote all these steps to that? Probably not. You could just go, if you want to go straight to the punch, you could go from here straight down to here, right? So anyway, Don't lose. If you take the shortcut here, don't lose sleep at night. Okay. Anyway, but I want y'all to see what's going on underneath the hood of the car, right? The mechanics of mathematics. Now, guys, at the end of the day, we know who 5 is, but if you write him like this, a parenthesis would probably be called for. 5 over 1. Okay. Any number is itself over 1, after all. Okay. Now, 5 times top times top, bottom times bottom. 5 times 13 is 65. So 65 over 7. Bring out your calculator, I guess. Okay. Now 65 over 7, playing with fire. Now, yeah, that's good. And would you forgive me if I go ahead and do something? 2 is cool. 2 is neat and nifty and correct and nice. But would you guys allow me to do something already? I know I'm going to subtract both sides in a minute. And I know that I'll need 2 to be, 2 can be thought of, my multiply top and bottom by 7 here, right? So 2 can be thought of, it's still 2, it's just written differently. 2 can be written as 14/7. It's still 2, it's just the actor is wearing a different mask. So I'm going to write 2 as 14/7. That way this denominator matches this denominator. And we can subtract at will when the time comes. And it's going to actually come real soon now. So Control C, Control V. And now I'm going to do Benedict Arnold. Now, that positive 65 over 7, well, he's going to Benedict Arnold and change uniforms. Like that. And now, see, I can subtract now, right? Well, so I get that. And well, but now by the consolidation law, I can bring the minus and the 65 up there. Now here's the deal. So that's neg. I need to be careful. I don't want to say something dumb. Well, no, I don't want to be derogatory or say something foolish, and I get clumsy sometimes. That's neg 51 over 7. Yeah, that's right. I don't think I did anything clumsy or goofy. That's neg 51 over 7. Okay. I guess I'll buy it. So neg 50, yep, I'll buy it. That's correct. So neg 51 over 7. And I could yank the negative out to the side if I wanted to. Let me leave it be. It'd be okay either way. You could. It'd be okay. It would be okay. But we're going to clean things up anyway. Now, I'm going to divide both sides by 6. And I know what you're thinking. That's cool. And that's cool as frost. You could go ahead and you could do that. But it would be a little bit grimy. Because if you divided both sides by 6 like this, you'd have to put parentheses around this, and it would be all grimy. It would be all yucky, because you'd have this, and there's a rule in algebra that says you'd multiply that 6 into that 7 and get 42, and indeed you would have neg 51 over 42, and that would reduce a little bit, but that's kind of yucky. That's awful, how shall I say, not fun. You could do it this way. I tell you what would be a whole lot more fun. Well, what you could do then is you could multiply 7 here and 7 here, and the 7s would cancel, and yeah, there you go. You'd get neg 51 over 7 times 6 is 42. You'd get neg 51 over 42. But that was awful icky. Can we find a less icky way? Yes, we can. I say we can. Let's do this. If I divide you by 6, is that not the same as multiplying you by 1/6? Would you agree? Sure. Well, you're not here to disagree, so Okay. I'll take advantage of the fact. Okay. Now, here's the dig. Here's the dig. Um, Notice how much prettier that is. What I did last time was valid, but it was awful. It was just so messy. It was valid, what I did just a minute ago, but it was so messy. I just couldn't enjoy it. Now, 1, 6, and 6 annihilate each other. Oop, I meant to go down the line. So they annihilate each other, and yeah, multiplication of a 1, 6 is the same as dividing by 6, but it's prettier sometimes. And another thing, cross canceling, we can cross cancel. 3 goes into 50. Guys, the rule of 3. If you have this, even if it's a long number, if the sum of the digits add up to a multiple of 3, then that original number is itself a multiple of 3. Long or short, doesn't matter. Now, 5 plus 1. And now, let's just take the negative. Well, first off, let's take the negative out to the side. Okay. Now, 5 plus 1 is 6. Hey, that's a multiple of 3. So 3 will go into 51. That doesn't tell us how much. It just tells us that it does. Now, does 3 go into anybody on the bottom? Nah, it doesn't go into 7. But it does go into 6, right? And so now 3 goes into 6 2 times. And 3 goes into 51. Check it and see. You'll get 17 times. I'm doing this. That's called cross-canceling. You guys ever heard of the thing called cross-canceling? And that's what I did here. This was called cross-canceling. Okay. Now, so I get, well, with all that being said, after we cross-canceled, if you don't have to cross-cancel right now, but if you neglect to cross-cancel, you're going to have to reduce bigger numbers later, and I just don't want to. Okay, so we have this. So it's going to be negative something, but hey, we can just come together. We got a fraction, that's just top times top, 1 times 17 over bottom times bottom, 2 times 7. Okay, and so that is just going to be, well, that's just 17 itself. We got our negative taken care of. 2 times 7 is 14. So I got neg 17 over 14, and we don't have to, and that doesn't reduce, and I didn't expect it to, because I did my cross-canceling, I did my homework, and I saved myself the trouble. So neg 17 over 14 is reduced, and it should be valid. So that's the good news. The bad news is I've not found my y yet. But, so now we have found our x, but we need y. Okay, so we need y. So how do we get y? Now, so we found our x, but we need y. So y was that the last, that was the last problem. Oops. So we found our x, but we need y. Wait, or did we already find y? Oops, I'm eating my words. Uh-oh, wait, we already found. Uh-oh. Hold on, wait. So let's go back and recap. What did we just do? What did we just do? Wait, no. Actually, we found Y. Y was the first guy we found. Just kidding. Actually, I'm just being foolish. We found Y, didn't we? Hold on. So I need to number these problems. So we found X. Okay, that was long. I've got X. Okay, where did I come from? Oh yeah, that's right. I plugged in Y to get X, didn't I? Oh man. Oh yeah, we had Y a long time ago. Okay. Well, I forgot where I came from. Okay. So a long time ago, a long time ago. Where was I? So let's see, a long time ago. I should have labeled these. I thought it'd be easy to go back and find and trace my steps, and boy, I was wrong. Okay, so neg 17 over 14. We got our x. Now I'm going to lose my momentum. Where's y? Y was neg 13 over 7. Okay, I remember now. So y was neg 13 over 7 from a long, long, long time ago. Okay. Okay, so we had 24x minus 20 equals 8. And but that was after we did a lot of that was after we lined up the x's. That wasn't the original problem. The original problem, here we go. Okay, this was where it started. And this is, I'll call this number 2, the next problem. Oops, I had to fall out of myself, didn't I? Okay, and again, just to recap number 2, we had 6x, 8x. I chose to solve by eliminating the x's first and finding y. So yeah, we found y a long time ago. And I set the problem up a long, long, long time ago. Now, so here's the problem setup. You remember we multiplied the top equation by 4. We multiplied the bottom equation through by 3. And why did we do that? Why did we do that? We wanted 24, the least common multiple. And but the price we had to pay, we had to distribute 4 across the whole top guy, 3 across the whole bottom guy. 4 hit everybody up top multiplicatively. 4 times 6, 4 times 5, 4 times 2. And you remember I told you to go ahead and do 2 first to get the 8 so you won't forget it. 4 times 5 is 20. And then the last thing you'll do is 4 times 6 is 24. And then you can and you should and you must get rid of the parentheses in the 4. So you got 24x minus 20y equals 8. And then analogously do the same thing with the 3 across the second guy, because you want, again, 24x is your motive. And you want these 24x's to subtract and annihilate each other. And then, so we go down here, and again, now we subtract because these are both, again, this here and this here where my cursor is, back on this previous page here. We want highlighted here. We want these 24x's to annihilate each other. They're both, the coefficients are both positive 24, so we have to subtract. We don't want to add and get 48. That's bad. We want these x's to go away, or we want the x terms to go away. So we eliminate the 24s, and since we subtract, since again the 24s have the same positive sign. And now, if one of them would have been negative and the other positive, we would have added, but that's not the case here. So you have to put parentheses. Now, guys, it's important. You got to put parentheses around the subtracted equation, because this minus sign is going to distributively hit everybody in here. So you're going to minus 24x. Now you're going to minus a negative 27y, and that's going to amount to adding 27y. But now neg 20y plus 27y is positive 7y. And then 8 minus 21, that really is neg 13. And so 7y equals 13. We divided both sides by 7. We got neg 13 sevenths. And then we did we plugged that back in, and I chose one of the 2 equations. It was the one at the top one, 6x minus 5y equals 2. But you plug the messy neg 13 sevenths into y right here. So 6x minus 5 times this y value equals 2. Now, it's a lot of messy, long algebra, but we ended up with negative, we did a lot of messy fractional arithmetic and algebra, but finally, we got neg 17 over 14. Now, we found our x, oops, but we don't need our y. We found our x. We're actually done. And I was wrong when I said this down here earlier, so sorry, but actually, we don't need to find our y. We found our x by using our y. Sorry, guys, by using our y. We now only need to find, we now only need to list. We don't need to find anything. We now only need to list our ordered pair. Can't spell. Go up. Be good, be good, be good, be good, be good to me. Be good, be good, be good, be good. Okay, so x is, now be careful guys, anytime you do an ordered pair, x comes first, right? So the ordered pair solution is neg 17 over 14, comma, and the y coordinate that we used forever ago was neg 13 sevenths. Yeah, because we did a lot of negative sign yank out. Yeah. Oh, actually, here it is right here, isn't it? Okay. So it's neg 13 sevenths. Oops, I need to stay in the command. So neg 13 over 7, like that. Whew. Okay, so there's that. Now, guys, a word of caution. Sometimes your x's and y's will both be negative. Sometimes they'll both be positive. Sometimes you'll have one of them negative and one of them positive. And sometimes one of them will be 0 and the other won't be. Sometimes you'll have the origin. It varies wildly, very wildly. So just don't get too spoiled. But anyway, yeah, these problems can vary wildly. And solving by x was more painful, but I'll be honest, solving by y may have been even worse. This problem, you just had to go through the fire on this one, kind of. It was just, this one was kind of tough. My numbers should be fine. I'll plug them back into Google, but I should be good. Wait, I've gone to a bridge too far. Wait, here's number 2, because to the left is number 1. This is actually problem 1 continued. I need to, yeah, this isn't it. This is 1 continued. But I mean, we're fine anyway. So here was number 2. We already knew that. So let's go make sure that that what I have is good. Now my solution here again was what? It was neg 17 over 14, neg 13 over 7. And now neg 13 over 7 can be thought of as neg 26 over 14, but I may just plug this into Google. Or I could have you guys do it. I mean, plugging into Google. Neg, well, if I multiply you by 6x minus 5y equals 2, can I do this in my head? 6x minus 5y equals 2. Maybe in high school. 6x minus 5y, 6, 14, 3, that's neg 51, 6, 14, that's neg 51 over 7, minus 5y, but that becomes plus 65 over 7. Let me see. Well, 6, 3, 51 over 7. And let's see. Yeah, that's neg 51 over 7. And then minus 5. You guys don't know what I'm doing here, guys. I'm just trying to check this. Ignore me don't ignore me, but just for like 20 seconds. I probably should cut this part of the video out. I'm just trying to check this in my head where I don't have to go back to Google. Minus 5y. That's going to become, but the minus is going to make a plus. And then 65 over 7. 65 is going to hit neg 51. And I'm going to get 14. It works. 14 over 7. So let's move along. And let me quit wasting your time. It worked. And I'm not just saying that to make myself look good. It worked. Okay. So, and I could also, by the way, we could also solve this by solving for y. I could multiply the top equation by 9 and the bottom equation by 5 and get 45s. But I may leave that for y'all. That was a workout. Wow. Yeah, you better get the same equation, same solution, right? You will. You better, or you've made a mistake. You'll always get the same solution. If you don't, something's off. Right. Now, okay. It doesn't matter. You could eliminate x first or eliminate y first. Doesn't matter which on which. Now, as far as system of 2D, that's good. Now, what if you have like decimals in front? Well, let me just consider, let me just go back to the guy we just did. And let me just nip it in the bud. If you have decimals in front, I don't want to spend a lot of time on decimals in front or fractions in front. Make it nice. The moral of the story is make it nice. So number 3, decimals in the front. So if you have 0.6 and then minus 0.5, I'm just altering this 0.2, and let's say I make this 0.7. I'm taking the guy that we just did. I'm taking the guy that we just did, and I'm basically sticking decimals in front. Notice what I did was I divided both equations by 10. So instead of 6 in front of x, it's 0.6. I divided the coefficient by 10. And instead of negative 5 in front of y, it's neg 0.5. And instead of 2 on the right side of the equation, it's 0.2. It's like turning $2 into 20 cents, a $5 debt into a 50-cent debt, a $6 into 60 cents, and likewise down here the same idea. But well, guess what I'm going to do? What if I'd have started with this? What if this would have been given to me at the front and I wouldn't have known about? How do you handle this? Just multiply all or both equations by 10 to get pure integers. And so you'll just do 10 times the first equation and 10 times the second equation, and you're done. So 10 times the first equation and 10 times the second equation. And so you have that. And guys, it's going to be the same problem we had before. Nothing is different here. Nothing is different. Nothing is different. So distribute 10 on through and go right to left. Go in a sort of a counter style. So bye-bye decimal, and bye-bye 10. And bye-bye here. Go across, bye-bye decimal, bye-bye here, bye-bye. Look at there. And then, but then just do what we did on the previous problem. Well, just do what we did on the previous problem. But anyway. And so there's that. And that's how you handle decimals. And guys, to be honest with you, what if I be real funny about it? Stick 0.06 here, 0.05 there, 0.02 here. What if instead of like 60 cents, I have 6 cents, and instead of 20 cents, I have 2 cents, and instead of a 50-cent debt, I've got a 5-cent debt or a nickel debt. And now, but okay. And likewise, what if I don't mess with the second equation? Could I do that? Let me see. Maybe not. Let me see. Should it matter? No. Hey guys, what if I don't mess with the second equation? I was going to do the same thing down here. What if I don't? Okay. You would leave 10, after multiplying an equation through, if you multiply a top equation by somebody, it doesn't really matter just so you counterbalance both sides, right? I'm going to be like a little mischievous kid here. What if I don't want to mess with this equation here? I shouldn't have to. Hold on. Well, I need to make the change down here, obviously. But now, this is division by 100. But this is still division by 10. So what you got to do is stick 100 here and 10 here. And you're like, well, Jason, that feels off to me. But it isn't, because it's an equal sign. If you just so you adjust both sides, you're fine. It's fine. Because you're making the left side much bigger, but you're also making the right side much bigger, so it's all the same. It's all the same. Well, you know, it doesn't matter. It's all the same. Shouldn't matter at all. I don't want us to be rigid in our thinking, or too rigid. Rigid enough to be correct, but not rigid enough to not explore, you know? Now, well, okay. What else? So let me just make these ordinary again, and so I can mess them up again for the time being. Well, what if I divide everybody by 11 here? Oops, I meant 11, sorry. And divide this by 11. And what if I divide everybody by 13 here? So I'm just being mean. I'm doing fractions. Fractions are dividing, right? That's all a fraction is. You're like, well, you know, boo-hoo. Well, I fix it. To undo division, you multiply. So you multiply, and I need to make, well, so I'm going to have to write this the way it's written up there. So you have 6, whatever. So I fix it. So let me write the newly messed up form. And how's this guy? How did I mess up this guy? I just fix it, you know? I fix it. So if I make something wrong, I want to fix it, or at least I'd like to. Now, stick 11 there. If I divide you by 11 to fix, and you don't like it, to fix you, I multiply by 11. And likewise here, I multiply by 13. Okay. Because that 13 is going to distribute, but what happens is 13 times 8 over 13 is just 8. That these 13s cross cancel here and here and here. You just get the original guy again. You get 8x minus 9y equals 7. And likewise here, the 11s kill each other, and you get 6x minus 5y equals 2. Look at there. Yeah, it's pretty cool. And you remember the good old days when I had, and you guys remember the good old days when it's nice to have a native equation around. Well, that wasn't nice. I think Word loves to jump down. I don't know. It gets the biggest kick out of jumping down. I don't know why. But guys, hey, tell you what. But no, you remember when we do 0.6 minus 0.5 equals 0.2? What is that? What are we really doing? We're just doing 6 over 10. But who is 6/10? That's 3/5. And who is 0.5? That's 1/2. And who is 0.2? Well, that's 2/10. But who is 2/10? That's 1/5. And you remember I did 0.8, 0.8, and 0.9, and 0.7. And we'll go ahead and do this guy too. We'll make him fun. I was going to not do anything with him, but I'll be fun about it. 0.8 is 4/5. 0.9 is, now 9/10 won't reduce. So 9/10, 0.7 is 7/10. Sure. Now, of course, now if I want to get back when we do the point 0.006, no, or point 0.06 rather, not 00, minus 0.05 equals 0.02. Now that's 6 over 100. Now instead of 3 over 5, it's 3 over 50. And instead of 1/2, it's 1 over 20. And instead of 1 over 5, it's 1 over 50. Like that. So you just multiply the denominators by 10. Remember, if you multiply the denominators by 10, that's like dividing by 10. And I could do the same thing down here, but I think you guys get the gist. Well, let me do it. Something interesting happens with 8, though. Let me do it, because something arithmetically interesting happens. You get 8 over 50. But who is 8 over 50, by the way? 8/50 is correct, but that's 4/25. I had to do it for that reason. I came to the party for that reason. And then now 9 over 100 is so stiff it doesn't reduce at all, and neither does, for that matter, 7 over 100. Okay, anyway, 4 over 5 is stiff, but 4 over 50 will go down. It'll go down a notch. Oops, that's not 4 over 20. 4 over 50 is, sorry guys, it's 2 over 25. Oops, sorry. My bad. I forgot to that's a 2 there. I forgot to make that a 2. So yeah, 4 over 50 is 2 over 25. I forgot to reduce the 4 to a 2. My bad. So I had my mind on the 50 so much I forgot about to cut the 4 down to a 2. So it's 2 over 25x minus 9 over 100y equals 7 over 100. Yeah. .08, 8 over 10. Yeah. 8 over 100 is 4 over 50, which is 2 over 25. That's correct. Okay, but anyway, so that's enough on the whole fraction dance and the decimal dance. Let's go back. Let's see if we can get back to. Okay, I think we've done enough arithmetic dancing. Now here, if you have several things like this, if you have a troublesome problem like this, how do you handle it? Well, what if the denominators don't all jive though? I guess that's the best thing I never thought of. Well, I made things worse. I was hoping to copy and paste it, and it's not going to roll, is it? So apparently, that's terrible. So let me just get rid of it. So I'll just have to remember. So I'll need to do, if you have something, well, let me just, for all that's worth, I may as well, I'll cook up my own. Oops. So let me see, guys. If you have, I'm not trying to do a long pause here, but if you have like 3/4 x minus 5/9 y equals, let's say, 7 over 12. And let's say that you have, yeah, this gets a little bit stringy, doesn't it? And let's say you have 5 over 6x minus, yeah, they're bringing the characters onto the ball field here. Let's say, 1 over 18y. I'll bring 18 onto the ball field. 1/18 y, and that equals, but 18's big enough though. and then minus 1/18 y equals, let's just, let me use 13. I'll make these numbers nice and big. I'm not going to solve this. I'm going to show you how to set it up, though. Get rid of these fractions. So 6x minus 13 over 18y. And let's just say that equals somebody over 9. Let's just say 2/9. That's good. Oh, well. Now, this is the doozy, right? Now, we've got several denominators going on, but we need the least common multiple of let's see, we got 4, we got 9, we got, well, we actually got 6. We got 4, 6, 9, and it appears we got 12, it appears we got 18. And that's going to equal, let's see, pick the biggest number, 18, and start finger counting. 18, 12 won't go into 18. They won't all go into 18. What about 36? 36 is looking pretty good, right? 36 is already it. 18 times 2 is 36. Start counting the multiples of 18, and you're already there. 36 is your guy. So what we want to do is just get it, line up your, get everybody over 36. So now, to turn 4 into 36, you got to, or to transform from 4 to 36, you got to multiply by 9. But if you multiply the bottom by 9, you have to multiply the top by 9 as well. Now to transform, see, we had 4 down here, and to go from 4 to 36, you have to multiply by 9. But remember, guys, the price you got to pay, though, if you multiply the bottom by 9, you have to multiply the top by 9. Now down here, we already had 9. Now we got to multiply by 4. But if you multiply the bottom by 4, you have to multiply the top by 4. Now let's go over here to 12. We already have 12, but to get 36, we need to multiply by 3. 36 is my LCM. But if you multiply the top by 3, you have to multiply the, if you multiply the bottom by 3, the price you have to pay is you multiply the top by 3. Okay. Now, let's go down here. 6 times 6 itself is 36. We want 36 always for this problem. But the price you have to pay, you multiply the top by 6. Now 18, we already have 18. We multiply by 2 to get 36. The price you have to pay is you multiply the top by 2. Now 9. 9 times 4 is 36. But the price you have to pay, you multiply the top by that 4 as well. Okay, that's how you do it. That's how you get everybody over 36. Now we know what our bottoms are, the denominators. They're 36. The top numerators we don't know. That's who we need to find. So let's copy and paste this guy. And I'm gonna go over here. Now 9 times 4 is 36, and 3 times 9 is 27. Well, of course we got 36. That was the whole point, right down here. Now 5 times 4 is 20, and we know who the bottom is. Now 7 times 3 is 21, and of course we know who's down here. 5 times 6 is 30. 6 times 6 is 36. 18 times 2 is, well, 36. 13 times 2 is 26. Making sure I can still multiply. I can. Yeah, 2 times 4 is 8. And of course, we know who's down here. The same old, same old. So 36. But guess what we do to the 36s, guys? Now, since we have equality, now it's only good when you have equality. You can't do this when you don't have equality. But since we do have equality, we can cancel all the 36s. But I really ought to justify why. It's because you can multiply both equations by 36. So if you multiply both equations by 36, let me get that guy over there. And let me just put so to multiply both. No, nope. Let me see. It's not being cooperative. So 36 there. Now you can only do this with equations, guys. Don't go doing this when you have expressions, okay? Promise me. Don't go doing this with the expressions. So like this, and like this, and so we got that. Okay, and oops. Okay, so we got, well, and all that's going to amount to is it's just going to kill the 36s in each denominator. That 36 on the outside for each guy. And well, that's just going to be what I suspect it's going to be. You're going to get uh-oh. Let me see, sorry. My computer got funny. So we got, well, let's do it. That's just I promised I'd go right to left. Let me be a little bit of a promise breaker, maybe. Well, no, I ought not to be. Let me see. If I get rid of, ew, that wasn't nice. So I got 27x minus 20y equals 21. And I've got, hey, I just got rid of everything, didn't it? Okay. And I got 30x minus 26y equals 8. So I've got these two equations, but now again, these are equations. So that, okay. Now 3 goes into 27 and 21. We get excited. We think we can divide equation 1, this top equation right here, by 3 maybe, but no, we can't. 3 does not go into 20. That kind of ruined the party. Now, we can divide everybody by 2 in this one, though, because everybody's even. So divide every term in the second equation by 2 and get the first one is just not cooperative. There's not a lot you can do. And okay, so we would get, I will guide you guys this far. I feel like I owe it to you. And we get 15 and we get 4. Okay. I do want to show y'all little tricks like that. I'm not going to swear I'm going to follow y'all all the way. So we've got that. I'm not saying this to be necessarily pretty to solve. I just wanted, the moral of the story wasn't really for me to solve this. It was for me to show y'all how to get rid of nasty fractions. Wait. Ooh. No, that ain't 15. That's not 15. That's 13. Sorry, guys. That's 26. If I divide by 2, well, and I need to show y'all my steps. First off, 26 divided by 2 is 13, not 15. Second of all, I need to show my steps. How did I get that anyway? So if I divide everybody by 2, I stick a 1/2 out here. That's what I get for skipping steps, right? Serves me right, huh? So if I divide everybody by 2, and yeah, okay. The 15 was good. The first 15 was good. The second one should have been 13 though. Now the 4 was good. Okay. Now guys, I'll be honest with you. This could, I don't know if I'm moralized to solve this. I could use technology, but that's cheating. 20 and 13 have no kinship. What's the LCM of 27 and 15? What's 27 times 5? 27 times 5 is 135. Will 15 go into 135? I don't know. What's 15 times 7? No, that's not 135. Doggone it. Hey, what's 15 times 9? Okay, 15 times 9 is 135. Yeah. You have to count by 27s. And you 27 times, and you know it's going to have to be a multiple of 5, or it would either be a multiple of 5, and if that doesn't work, you're going to have to do it. They're not relatively prime. It's not, you don't have to do 27 times 15. They do have 3 in common, right? You want me to show you a little dirty trick to find the least common multiple of 27 and 15? The least common multiple of 27 and 15. I don't show this often because it's not always well received, but you can do this. 27 is 3 times 3 times 3, right? And 15 is 3 times 5. Okay, so pick, so that's just going to equal which term has more 3's? Which term has more 5's? Well, obviously the first one. Well, the 27 term. The 27, and then which term has more 5's? Evidently the 15, 27 doesn't have any. So we're looking at this factor tree here. 3, 3, 3 is 27. 3 times 3 times 3. 3 times 5 is 15. Now, pick the 3's off the 27 tree. Now, when I say a tree, when I say tree, I'm talking about this guy right here. This is a little tree. Treat this like a holiday tree. You want to get all your 3's off this tree. You can't use this 3 here. You got to use this 3. You got to pick all your fruit off this tree. So so we get 3 times 3 times 3, and then obviously pick the 5 off the 15 tree. No other choice. So the only 5 you got to pick is this one. Now we can't use this 3 here. It's against the rules. You pick from the tree with the most generous fruit, but you can't pick the 3's off the lesser trees. It's called the prime. It's the least common multiple. Pick from the most generous tree idea, but you can't pick from the second most generous tree, or for that matter, from any less generous tree. Okay, now 3 times 3 times 3 times, that's 27 times 5, and that's going to be, yep, that's 135. Sorry, 135. So 135 is my least common multiple. That's another way of getting it, but anyway, so you multiply, so it's 27 times 5, so we multiply the top equation by 5. So, well, so if I multiply the top equation through by 5, and now 15, how do we know what to do with 15? I said it was 15 times 9. Jason, how do you know that? Because 15, let's look at 15 as a tree with fruit. It's got the prime number fruit. 5 times 3 is 15. But now, but we know that the guy we want, the 135, is 3, 3, 3, 5. But 15 is just 3, 5. We need 2 more 3's. So we need 3 times 3 is 9. So we need 3 times 3, right? We're missing 2 3's. We need 3 times 3. So we need 9. Because we need this. And we're missing these 2 3's here. So we need 9. And if you don't like that, you can just use your fingers and start counting. You can get 27 and say, look, 27, 54, 81. The next guy in line is going to be 81, and 27 is 108. And then 108 and 27 is 135. And sure enough, 15 times 9, 15 times 10 is 150. And if you subtract 15 down, that's 135, and that would have to be the 9th multiple. But that's another way of doing it. Anyway, I don't want to do 20 times 13 for y I don't want to eliminate y. That's nasty. That's going to get big. That's 260. Y, 13 and 20 have no kinship at all. Well, this is going to be pretty nasty, but y would be worse, I think, or I'd be afraid. Now, so if we do this, that's one. I said I wasn't going to do this, but I guess here I go. I'm kind of doing it anyway, right? Let's see. If you do 5, who do you get? you get 135x. You get that's 100y, and that's who we get 105. And if we use 9, well, of course, it's 135. That's what we said. And then 9 times 13, that's a little steep. The 27, and then that's 117. Yeah. And then, yeah, 9 times 13, yeah, 117. That jobs. And then 9 times 4 is 36. Yeah, don't forget to do the 4 now. So we got that. And then Control C. This may not be as bad as I thought. And then, well, so Control V. And I want to put, now these are the same coefficient negativity. They're both positive, namely. So I subtract. And then, well, I get that. So I subtract them. And, well, if I subtract them, now be careful. You're minus in a neg. The 135s die. Now, neg 100 plus 117 is actually positive 17. So what do we get? We get positive 17y equals, now 105 minus 36 is 69. Yeah. Now divide, and then just divide both sides by 17. And y equals 69 over 17. Now, guys, 17, will this reduce? It had to, 69 would have to be a multiple of 17. I don't know. 17 times 4 is 68. So there's no way. It doesn't not reduce. I did need to check, though. But y equals 69 over 17, and that is it. We have done y. Now, and then you just plug y back in. Then plug y back into an original. Equation to find x. Wow, yeah, what a rush. I'll be honest. No, not an original, because no. Plug y back into a. How about we don't? How about we do a non-original equation with integers? Because the originals are nasty with fractions. How about we don't use an original? How about we use something more modern that we run into later? How about we just use this? I don't want to go back to the original. I know I might use the original at the very end with Google. But now 15x minus 13y equals 4. I'll have to use the original to check my work. But now what about 15x minus 13y equals 4? So 15x minus 13y equals 4. I'm just going to use, you could use something else now. I'm in the mood to pick this guy. This is a multiple of the original, or it's a linear combo of the original. So it's, by the rules of linear algebra, it's equivalent to an original. Because it's like, we got it from the original. It's a derivative of the original. But anyway. Well, let me just put it this way. I probably had better put it this way. It's a derivative of the original. I probably better be a little careful with my language. It's a derivative of the original. But anyway, so we have 69 over 17. Okay, so we have that. And then Control C. And then Control B. Okay, well... Yeah, well, actually, we got this by, actually, it would be a multiple of the original. We got it by just doing a whole bunch of, we took the original and we multiplied it by a bunch of stuff and divided by some stuff. Yeah, so yeah, we divided by 2, multiplied by half is the same thing. Yeah, it's a multiple of the original. Sure it is. Yeah, the original, we multiplied the original by 36. And then we redivided it by 2. So in essence, we multiplied the original by 18 is what we did. If you multiply this original guy here by 18, you'll get the guy that I'm using now. That's something I feel like you guys ought to know, or well, ought to be aware of. And that's something I ought to be honest with you all about. This is just the original multiplied by 18, but both sides are multiplied by 18, so no harm is done. And I'm plugging this new guy into this, and it's equivalent to plugging it into the original. Okay, so, well, now, if I do the arithmetic here, oh, that's awful. So, I don't feel it. Ow. Yeah, that makes my head hurt. So that's going to be, well, I'll be honest, Control C, Control V, and what's going to happen is that 13 is going to go up here, and it's going to multiply that 69 like that, 13 times 69, and then, so we get that, and then what's going to happen to is Control C, Control V, 13 times 69, let's see, 690, 3 times 69, 3 times 9 is 27, that's 207, 207, 690 and 207, that looks like 690 and 207, 897, that looks a lot like 897, but I'm afraid to get that big. 897, I want to say, but that's getting awful nasty. See, yeah, 10 times 69 is 690. 3 times 69, yeah, 207. And then 690 and 207. It would be 897. But that's getting awful rough. Now 69 is 3 times 23, so it's 13 times 3 times 23. But all those are prime, and none of those are 17. 3, 13, and 23 are all prime, and none of them, and 17 is prime. So no canceling occurs here. So because 3, 13, guys, the moral of the story, 3 times 23, if you look at this guy here, 13 and 17 are prime, so they're not going to cancel. 3 and 17 are prime, and they're not equal. 23 is prime, and it's not equal to 17. And because 897 is combustible into these three guys here, it's not going to cancel with 17 at all. Now, we add this to both. We Benedict Arnold. So Control C, Control V, and I don't really, this parenthesis here has no business being here anymore. So let me, I can just get rid of that parenthesis and just write 897 over 17. Now, I tell you what I could go ahead and do. So it's 897 over 17. Let me multiply both sides by 17. 15 times 17 is not, I could do it, I think. It's not fun to do. 15 times 17 is 150, and 105 is 255. So 15 times 17 is 255. Oh, mercy. Wait, 15 times 17. Well, wait, hold the phone. 15 times 17. 15 times 17. Hold on. 15 times 17. 17 times 10. Wait, is 170. I'm afraid it's 275. Because, let's see, 17 times 10 is 170. 17 times 5 is 85. No, it's 255. It's 255. I had it right the first time. And then 17 times a fraction over 17 is just the numerator, 897. And then 17 times 4 is 68. So I multiplied everything in here by 17. times seven, and what I did, and I'll copy this guy and I'll paste. So I multiplied everything in here by 17 to kill that. And my motive was to kill this denominator of 17 here. Okay, so I did that. And then I add 897 to both sides, and I get 255x equals 897 plus 68. Well, that would be 965. And then I divide both sides by x, and I get 965. X equals 965 over 255. And now reducing this will probably be hard. Who knows? There's no real. I can tell 5 will go into things. Let's see, 1930, 193 by the. Like if you doubled this, it would have been 1930, right? If you'd have, but you slice the 0 off. Like there's a rule that says if you multiply somebody by 2 and he ends in a 0, and then you slice that 0 off, you have divided him by 5. Okay. Now if you divide this guy by 5, like if you make him twice as big, he's 510, but slice off the 0. So that's 193 over 51. So there's x. And well, now 3 times 17 is 51. Now 193, 1 plus 9 is 10, 10 plus 3 is 13. 3 does not go into 13, so that's out. Does 17 go into 193? 17 goes into 19 one time. 17 goes into 23 one time. Remainder 6. No, there's a remainder of 6. So that's out. 3 and 17, neither one do, so it's over. It's over. That's it. So there's x. Now I have my ordered pair. X comes first now, right, in an ordered pair. So assuming I didn't make any arithmetic mistakes, it's 193 over 51, comma. Now we had y a long time ago. I think it was 69 over 17. Yeah, so y was 69 over 17. So 69 over 17. Wow, okay. So there's my y. You remember y comes second, okay? Now, here's the gig. I could plug this into Google. I don't know if I've got the courage. 193 over 51 and 69 over 17. 193 over 51 and 69 over 17. I'm afraid it would bother me if I had it wrong. Guys, if it turns out wrong, that means I made an arithmetic mistake somewhere, but I didn't really come in here to solve this as much as I just came to show y'all how to get rid of the fractions. And really, to be worth my oats and metal, I would have to plug it back into these originals here. And really, it's got to satisfy both. One thing I didn't point out that I should have pointed out a long time ago, in any given set of equations, it's got to satisfy both equations. If you plug it back in to check it, really to check out a solution has to satisfy both of the originals. It's not enough to satisfy one original. You really need to satisfy both originals, okay? And I need to bring that on home. You need to satisfy both of the originals. I didn't amplify that earlier, and I should have emphasized that point. Now, I'm too scared. Okay, I'm too chicken. So I got 3/4 x minus 59y equals, well, let me copy this guy. I'll put it into Google. If it's wrong, I don't know if I can swallow my pride. So 3/4 x minus 59y equals 7/12. So I got 3/4 x. Now Google, so I got 3/4 x minus, Google probably want parentheses, 5/9 y, and that equals 7/12. I'm too scared to plug it, just about to plug it in. But you guys, if you understand how I got rid of the fractions, you've understood what I wanted you to get. And that wasn't anything private, so it's fine. Now, uh-oh. Wait, where's my Word file? But anyway, I wanted y'all to just understand how I got rid of those fractions. I didn't really mean to go off on a hard tangent here. Y is 69 over 17, and then X is 193 over 51. Okay, so X, you'll need parentheses, 193 over 51, and Y is, wait, let me make sure. Now, I don't want to tell, I can't tell Google what to equal. And Google may want times signs. It probably will. And let's see, guys. What was it again? 190. It's 69 over 17 for Y. Oh boy. Okay, so what do we got? Oh man. Now, what answer should I expect? 0.708, 605, 6648. Okay, that's decimal mode. Now, wait, 69 over, not 18, 69 over 17. Sorry. Yes! Okay. 0.5. I think that's it. I think that's it. Let me see. I don't want to get too excited, but I think that's it. Wait. Now to check, I need to go to Word. And I need to go, what was my original problem again? Now, I know what you're thinking. I need to check the other equation too. But usually if one's right, the other will often be right. You do need to check both. And I don't want to be a bad influence on you guys. And this is my next problem. And another thing, another promise I'm not keeping is this is my next problem. This is where it started. I'll call this problem 4. So, 7 over 12, is that right? Is 7 over 12 is wait, no, this is that the 7 over 12. So I got yes, the number is awful pretty, and 7 over 12, 3/4 x minus 5 minus y equals 7 over 12. 3/4 x minus 5 minus y equals 7 over 12. Let me yes, got it. Okay. Oh well, and let me make sure, and just to be double extra sure, let me use parentheses. Yes. Okay. It's correct. Okay, so we have reached the. I did it. Okay. Now, the next thing I need to show you guys. Okay, we've done our do with fractions. That was something else, wasn't it? Now, if they ever give these to you guys out of order, so we'll move along from fractions now. That was a workout. If they ever, by the way, the next one I really won't solve. I'll keep my promise because that probably took too long. If they ever give you guys something like x over 3 minus y equals, like, let's say 1/2, and if they ever give you something, and then let's say they turn around and give you something like x minus y equals 1/6. I'm not going to solve this guy. I'm kind of getting bombed out on doing some of these, but no, I'm proud to help y'all, guys. The least common multiple this equation right here is, well, the least common multiple of 3, 2, and 6 is 6. And so let me see. And to be honest with you, if you want to rebel and just do the least common multiple of this separate from the least common multiple of this, and I know that's what some of you are thinking, and I alluded to that earlier with the tens and the hundreds. You can do that. I'm just going to do it all together. You can also do that. I'm going to do the LCM of all of this, but actually it doesn't matter anyway. In this case, the LCM of 3 and 2 is 6, and if you include 6, it's not going to change anything. It doesn't change anything. The LCM is 6, so it's a really no avail anyway. So I'm going to multiply this by 6. The least common multiple is 6, any way you cut it in this one. And 6 here. So I got 6 here and 6 here. And what's going to happen is you're just going to distribute 6 through, and you can go ahead and just do, there's two things you can do. You can write this as 6x over 3, and but what I'd rather do, guys, to be honest with you, is let me see. I had rather just do 6 divided by 3, and that's 2x. Now, if I go ahead and distribute the 6 on through, 6 divided by this 3 is 2x, and then minus. Now, 6 times y, you got to do that wholesale. That's 6y equals, now 6 times a half, that's 6 divided by 2, that's 3. And then now 6 times x, now you need to get rid of all fractions, even if they're on the solutions aisle. So you got 6x wholesale minus 6y, and let's be a rebel. Let's put a 4 there. Now 6 times 4 ultra wholesale, that's 24y. That's the price you got to pay. Now 6 times a 6 is 1, right? Notice you had to make this ultra big. You had to make this 24 in order to get rid of this fraction here, right? And let's say that 1/6 would have been a 5/6. Then this, you'd still did this 6 here divided by this 6 down here, and that would have left you with 5 here, right? Now, be careful about something. When you have an equation like this, if I were you, what I would do is, now this -6 will not kill this 6 here, because this goes with a y, this goes with x. You can't do that, right? There's several things you could do. What I might be tempted to do is just go ahead and just take these two. This one is actually pretty easy to solve. It should be multiply. If you want to go ahead and cancel your x, may be real easy to do. Just line up your x's. How about I'll line up my y's. Let me do something different. Well, or the same, doesn't matter. I'll line up my y's. So I'll make y 24 here. Notice 24 is already a multiple of 6. Let me solve this guy. So 24 is already a multiple of 6, so let me multiply by 4. Well, and we don't even need to do anything here. So we get, so if we multiply this equation by 4, well, we get, so I'm going to copy this guy on down. Distribute 4 through. That's 12. That's 24. That was the reason why we did this. That's 8. Now, this has got to go. And then scoot back over a little bit. So there we go. And then the whole reason we did this was to line up the 24s. And so let me copy this guy. And we just do the same stuff as we did before. And you could subtract the top from the bottom, but I'm too lazy. Really, it's probably just as well to do it this way anyway. So I'm going to subtract. And then do this. You know, you have liberty. My way is not the only way when you do these, right? It's understood underneath the hood you have some liberties. And then put my usual thing here. And then you're going to get, well, now 24, now minus a neg is plus, but neg 24 and plus 24 killed. That was the whole point. Now 8x minus 6x is 2x. So we get 2x equals, and 12 minus 5 is 7. And then you just get x equals 7/2. Like that. And then just finish from there. I will leave it to you. Instead of going, well, one thing I will say, instead of going back to the original, maybe use an integer multiple of, don't use a dead original, maybe use, say, it's okay to use, I would just use 2x minus 6y equals 3. 24 is okay. This second guy's okay, but 24 is a little big, you know. So maybe just use this one, the first guy. You could use the second guy just fine, but the first guy looks prettier. So just for neatness, you could use now if you don't use the original because it's got those messy fractions. You could just use this. Sometimes going back to the original can be too messy if it has fractions in it. But we know who x is. X is 7/2. And then now 2. Okay, but that's pretty. That was actually real pretty. And 2 times 7/2 is just 7. Well, here I go. I'm kind of doing it again. But Control C and Control V, and then just do Benedict Arnold. That's going to be 6y over here, and plus 3 jumps over here and becomes -3. And I think we're going to get the idea. That's just positive 4 equals 6y. Yeah. And then divide both sides. Well, I was hoping to finish it on this. No, I got to jump. So it's going to jump to the other page. 4 equals 6y. Divide both sides by 6. Now, 4, 6 is good, but that reduces, right? Control C. That reduces to 2/3, right? 2/3. So y is 2/3, and that now but x always comes first. So 7/2. The ordered pair is 7/2 2/3. And so it is. But yep, there it is. But yeah, and guys, if they ever give you opposite signs from the start, let's say they give you neg x plus y equals 11, and let's say they give you well, let me make it a little spicy. Let's say put a 2 in front here, 3 in front here. And let's say they give me 2x plus 5y equals 4 or whatever. Notice we'd be crazy not to cancel the x's. Now here we add. We don't subtract this time. We don't subtract this time. We add. We add the equations, right? So we add the top to the bottom, or and we just get, if we add the top, well, we add them because they have opposite sign, right? Why? Because we add the equations because the matching coefficients, and I'm going to abbreviate, sorry, have opposite signs. Well, it's not going to let me. Have opposite signs. Okay, so we take these. I might as well go to the next page. So Control V, scoot over, and I'm going to put my plus sign in my parenthesis. You could add them in whatever order. I'm just going to add them in this order. You could switch the ordering, as always, right? But I'm too lazy to switch the ordering. Let me just do, yeah, that's good. Now, the X is canceled. That was the whole point. And I wish there was a shortcut to insert equation. But anyway, 8y equals 15. And then if I divide both sides by 8, I get, well, y equals 15 over 8. And then from there, you just plug 15 over 8's in to get x, right? And then get x from there by substitution. This is called substitution, by the way. I should have pointed that out long ago. Oops. But you guys get the idea. So, and I'm going to just use this guy. You could use the other guy just the same, but I'm going to use this guy. So 2x plus 5y equals 4, but we know who y is. Y is 15/8. So, yep. And now by algebra, so we got Control C, Control V. Now, remember, 5 is really 5 over 1, right? And I'm going to just cut to the chase, multiply the numerator only, because 5 is 5 over 1. So we get, that's 75 over 8. And, but anyway, that's 75 over 8. And if I write it like that, I ought to probably use parentheses. Now, and now the parentheses are foolish if I do that. So 75 over 8. And now, okay. Now let me just copy this guy. And it's going to be pretty, and you guys know what to do from here, right? You want 4 to have a least common denominator, 32 over 8, just to make your life easier later. And then you just go through the motions, right? It's just like a broken record. You Benedict Arnold, 75 over 8. So it's minus 75 over 8. And then you, I may as well go over here. You can co-marry the numerator. I put the minus 75 up here. It's just a big, long arithmetic haul. Now that's going to be a negative number, 43, I think. Yeah, neg 43 though. But, you know, we can yank the, let's just go ahead and yank the negative out to the side. Okay. And now here's the deal. I can multiply both sides by 2, but it's prettier to multiply by a half because we're dealing with a fraction on the right-handed side. And things get sticky, as we saw a while ago. That's been earlier in the video. So let's multiply both sides by a half. And then what you do, you got to use parentheses or it'll get unwieldy on you. So like that, 1/2. Whew. Okay, so, and by associativity, and I should have also mentioned associativity, the half will kill the 2. And let me create it, just for neatness, let me create a little space there. It's correct, it's just gaudy. So 1/2 times 2 is 1. And so, well, who do we get? We get Control C, Control V. Now, but who do we get? X equals, now I can yank the neg out to the side here. Now 1 times 43 is 43. We top times top, bottom times bottom. And 2 times 8 is 16. So it's neg 43 over 16. You can literally put 1 times 40, stick the neg out to the side, but otherwise 1 times 43 over 2 times 8 on the, and 2 times 8 goes on the bottom. Okay. So there's my x, and so my y was this, my x is this, and I'm just going to write. This should be right. I don't see. I'm not going to check it, guys. I don't feel like it, but I'll leave it for y'all to check it and send me a message if it's wrong. I don't think it. I'm 95% sure it's right. I'm actually 95% sure it's good. There's no reason. Yeah, I was real careful. I don't feel like plugging this into Google. I just don't. So your ordered pair would be neg 40. I'll put the ordered pair in. So it's neg 43/16, comma, positive 15/8. So yeah, there's a unmatching signs for order pair, which it happens. We've not seen it in a little bit. And I did need to check if this would reduce, but of course 43/16 does not reduce. But anyway. But I just, moral of the story, there are situations where you add at the very beginning, and this time we did, right? So it happens. Anyway. Oh, wow. We've covered a lot of ground, and let me get a swig of water. Give me a 10-second pause break here, and just let me get a swig of water. You're going to hear me go quiet. Don't freak out and think the video's going bad. It's not. Just a second. My voice is getting a little scratchy. Sorry, guys. Just getting a swig of water. Okay. Now, I had to wet my throat. Well, now sometimes you get what's called a dependent system where you, well, what happens to you is you don't really have two different equations at all. You won't get one answer. You'll get infinitely many answers. Like let's say that you get let's say you get 2x minus 3y equals 7. And let's say that you get let's say that you get 4x minus 3y, and actually there's also the case where you'll get no solution at all. I need to amplify that. But let's look at infinitely many first. Or like 4x minus 6y equals 14. There's the and so problem cases. Problem cases, infinitely many solutions, and no solutions at all. Oddly, you'll never have a case where you have like 2 or 3 or 5. You'll either have none at all, infinitely many, or 1. You'll never have something like 5 or 7 or something. You know, it's 5 solutions or 1 or sorry. Of course, you can have 1 solution. You can have 0 solutions or 1 solution or infinitely many. Like you can't have 2 solutions or 3 or 4 or 5, or you can have infinitely many or none at all, or you can have just 1. That's it. But because if you think about it, I'll show you geometrically why. It has to do with lines intersecting. If they're parallel, you have no solution. If they overlap, you have infinitely many. If they're not parallel, but they don't overlap either, if they just kind of cross at one point, well, you have 1 solution and only 1. And that's the lines we really care about, and that's the lines we've been doing the whole time. But anyway, let's give this a look. So we have this guy here. Now, if I multiply equation 1 by 2, right? Either which, any way you cut it. If I multiply equation 1 by 2, if we do, we get. Well, what do we get? We get. Let's see. Well, we do that. So, well, now we get. Well, we get 14 over here, and that wouldn't necessarily scare us. Now we get 6 here. We get a little nervous, but we're okay. Now we get 4 here, and we're toast. And what happens is, now, guys, what's happening is these are the same equation. And let me just go up here and I'll copy these. And I don't usually copy them this many times. It's okay. Extra never hurts. Well, we don't notice we don't really we don't really have two different equations. So really, we only really have 4x minus 6y equals 14, right? So we really only have that, and it's good table manners to go ahead and divide both sides by 2, which is, and I'll have good table manners. Let's divide everybody by 2. It's an equation. I can do that. So we really only have 2x minus 3y equals 7. But all that aside, we only have one equation is what's really important here. Okay, we don't have 2 lines. We just have 1 line. What's going on? Our 2 lines overlap. Our 2 lines totally overlap. We have infinitely many solutions. Instead of 2 lines the whole time up until now, our solution set has been a single ordered pair. Has been a set consisting only of a single ordered pair of numbers, a single ordered pair, denoting where the lines cross in the 2D grid, right? Or in the classic 2D grid. Okay. Our lines have never been, or so far, our lines have not yet been parallel. Have not yet been parallel or overlapping for that matter. They have neither been parallel nor have they been overlapping. But now we've got an overlapping guy, right? I'll talk about parallel in a minute, but right now we're doing overlapping. So we've got overlapping. So we have 2, but now we have 2 overlapping lines whose equation whose same equation is, well, 2x minus 3y equals 7, right? Well, this is it too, but this can equivalently be written as 2x minus 3y equals 7, and that's the better table manners way to write it. 4x minus 6y equals 14 is the same as 2x minus 3y equals 7. Now, guys, here's the thing. Now, with finite math, you don't escape algebra. Here's the thing. The solution set, if we solve for y in terms of x, if we solve for y in terms of x, we get y, well, we get so y equals f of x. Well, but who is f of x? Well, let's see. If we solve for y, so, well, what do we get? So what do we have? We have 2x minus 3y equals 7. Now, what's that saying? Let's do Benedict Arnold. I have 2x. I moved the 7 over. I moved the 3y over. Now, if you divide both sides by 3, that's basically you're dividing every term by 3. So you get 2x over 3. But that's just, that's cool. But you know, that's 2x over 3 minus 7/3. Let me skip break a line. So, word, I'm getting on my nerves. 2x over 3 minus 7/3 equals y. But guys, 2x over 3 is gaudy. 2x over 3, that's just 2/3 x, right? It was correct, but that's gaudy. X is indeed, x is understood to be up here in the numerator with the 2, but it's better table manners to put it out to the side, okay? Now just don't put it in the denominator. That would be a mistake. X is indeed understood to be up here with the 2. It always is in the numerator with whoever the numerator coefficient is. But anyway, so we have that. So, in other words, y equals 2/3 x minus 7/3, right? So we have that. Then our ordered pair in terms of y would be, well, no. In terms of x would be, we're in terms of x. It would be the set of all xy. It would be the set of all ordered pair x comma y. It's infinitely many things, such that it's the swervy swirl bracket. It's the set of all x, y, and the vertical bar means obeying. The set of all x, y. Well, forget that. Let's just do this. It's x comma, and x is just x, and y is 2/3 x minus 7/3. Okay, and then close swervy swirl. So it's a collection of infinitely many things, not just one thing anymore. We've been doing one thing forever and ever now, but now we're not. Now that's dandy. We have written everything in terms of x. X equals x itself. Now y though equals 2/3 x minus 7/3. Okay, and indeed we're linear. This is everything here. These are lines. All this is one big line. Right, we've been doing lines and lines galore. Now, what if we want x in terms of y? Well, let's copy this equation again. Well, then what I do is I copy over, and I'm on a Benedict Arnold, but this time I want to get x by itself. And I add 3y to both sides like that. And then I'm going to copy that guy. And I kind of did y messy. I'll try to do x more neatly. Divide both every term by 2. I'm dividing both sides by 2, but that's just the same thing as dividing every term by 2. Another thing, before I do that, would y'all forgive me if I did one thing? This is correct. Nothing is wrong. Nothing is wrong. But let me do... nothing is wrong at all, but let me just, by commutativity, let me put the 3y in front. I love my y's in front. It's just nicer, you know? And now I'm going to divide both sides by 2, which is the same thing as dividing every term by 2. So that's going to just get rid of that. And that's going to, now that's 3y over 2, but that's gaudy. Correct, but gaudy. I'd rather have this. And then I'd rather have this. And I know what you're thinking. That's 3y. You could put the y up there with the 3, and that's correct. But I find it kind of awkward on the eyeball. I like to have the y out to the side. Okay. And indeed, the y, if you put the y somewhere in the fraction, it would be in the numerator for sure. At the top numerator. But I like to just have it out to the side. Okay, so we have x equals 3/2 y plus 7/2. Okay. So then, now, if our set of ordered pairs would then be, for our overlappers, would then be, actually, you can just pretend like we just have one single line, right? You could just ignore one of the overlappers because it doesn't contribute anything, right? So insert equation, now here, guys, here's the dig. You would actually you'd put the complicated thing first. No. Sorry, that was bad. So we have 3/2 y. You'd put the complicated thing first, and then comma, and then comma, then you put your y second, because y is the simplistic thing this time. Oops. Uh-oh. It would be, I forgot my parentheses. Always forget something. So it's the set of all ordered pairs. And really, this is correct, but I ought to have left more room. That was kind of gaudy too. It was right the first time. I just wanted to leave a little more. I don't know. In a way, the space makes it gaudier. Let me make the Y. That's gaudy. Let me make the Y close. Yeah. In a way, the space made it worse and not better. So it's the set of all ordered pair such that x equals this guy here. X always comes first. Now, y is just himself because we're in terms of y. X is written in terms of y. Whereas if y is written in terms of x, we're like this. Okay. So that's if we have infinitely many solutions. And that one is kind of the royal pain. Okay. If one equation, we always have infinitely many solutions. If one equation is a non-zero, you don't want zero, but otherwise you're fine, is a non-zero multiple of the other equation. So just if one equation is a non-zero multiple of the other equation, you'll have infinitely many solutions. Okay. Now, however, on the other hand, but what causes no solution? This is the other scenario. If the let's see, it's almost better demonstrated than said. Let's say that I have 2x minus 5y equals 9. And let's say that I have let's go back to the well, but let's say that I multiply the right-hand side by 2. 4x minus 10y. Well, I would have infinitely many solutions if I put 18. And I know what you're thinking. Well, he's going to put 18 and have infinitely many solutions. But let's say that I'm mean. Let's say that I put 20. Or just anything else. It could be 17 or 20 or anybody but 18. 18 would have been fine. I'd had infinitely many solutions. Oh boy. What causes no solution? If the left-hand sides of the two equations, if the left-hand sides of the two equations are a multiple of each other. How do I want to say this? If the left-hand sides of the two equations are a multiple of each other, but that multiple does not correspond with the right-hand sides. Oops, with the right-hand sides of the equations. And well, let's see what I mean by that. Well, let me go ahead and let me copy these two equations down. Notice I didn't use 18. We get, and let me just go ahead and scoot on over here. Now, guys, I'm telling you what, I'm gonna divide. I'm just gonna go and do what I did before. Put parentheses around this guy. These are all even numbers, and at first we might not see the trouble. I'm gonna divide by 2, which is multiplied by half, and you may not see trouble at first. Everything may seem fine to you, but I see trouble on the horizon, though. I see trouble, and I see plenty of it, and here's why. I'm dividing by 2. Multiplication by half is division by 2. Okay. Uh-oh. See, 2 is the multiple, or you could also say a half is a multiple. But, guys, on the right-hand side, by 2 is not the multiple at all. Not even by any stretch. Uh-oh. Uh-oh. So, uh-oh. Look at what we're saying. We are now saying, look here, guys. I'm referring to this, what's here in blue here. Look what's here in blue. Look at what is highlighted here in blue, okay? We're saying that 2x minus 5y equals 9. That's okay. But we're saying that the same thing, 2x minus 5y, is also equal to 10. And that would be okay by itself, but you can't equal 9 and 10 at the same time. That's not okay in conjunction with 9. You can't be equal to 9 and 10 at the same time. We are saying that the expression 2x minus 5y equals 9 and 10 at the same time. This is absurd. No solution. Don't try to, if you try to solve this, even if you tried to solve this, you would get the x's and y's would what would happen to you? You would get a contradiction like or such as 0 equals 1. Which is that's an absurdity, right? Which is not true. That's an absurdity, right? Okay. So there's no solution. Now, how do we write this? You just type EMPTY in your computer program. In set theory, we denote this anomaly by just the empty set. Swervy swirl. Let me use the Purdy editor. There's several ways to write it. There's like the Greek symbol for it. Slash imp. Well, not that. Well, they used to have the empty set. There it is. There it is. See that little thing there, guys? This is the empty set. Another way of writing it is just the good old-fashioned slash slash, the set of nothingness. You have no solution. You don't have one. These are 2 ways of writing the empty set. You have no solution. Now, don't put 0 in there. 0 is not a solution either. Guys, don't go putting 0 in there. Is not because 0 is not that. 0 is not a solution. 0, we would have a solution, right? Sorry, 0 is not a solution. We don't have one, right? Well, you have to put ordered pairs anyway, right? But anyway, indeed, the origin, or 0, 0, is not a solution. You can't use the origin either. You don't have anything. You have nothing. It's not a solution either. You're out. You're out of luck. Because you can't make some, if you go back up here to what I'm highlighting here, you can't make somebody equal 9 and 10 at the same time. The origin won't work. Nothing works. You're out of luck, right? Don't try. But anyway, yeah, you're flat out of luck. So that's how you take care of the empty set and the infinitely many solution situations. I'll have to, well, I'd like to do 3D. I know my time is kind of getting on the skinny now. I got somewhere to be in a few minutes. With 3D and with matrices, well, there is one last thing I want to talk about. I better just stay with this. I've got to quit pretty soon, but yeah, I better just stay with this. Let me. I'm not done just yet, but I'm almost done. If they give it to you out of order, if they say like x plus y, or let's say they give you 2x minus 3y equals 7, but let's say they give one to you out of order. Let's say they give you 3y equals 7 minus 5x. Get this in the right order. Okay, so the first one's good. So you got 2x minus 3y equals 7. And now this one, the second guy is all messed up, right? You got to get him in order. So you want a Benedict Arnold. The neg 5x comes over here as positive 5x. And now 3y was already here. He's good. So plus 3y and then equals 7. And you can actually solve this guy really nicely. And I think you'll get like x equals 1. And now y is going to be a little messy. Y is going to be like 2/3 or something. But anyway, if x is 1, I guess this is, if x is 1, then y is, if we add these two equations, wait, no, x won't be 1, guys, sorry. No, it won't be. X would be 2, because you get 7 plus 7 is 14. And then 7x equals 14. X would be 2. And if x is 2, you get 10. And then y is not going to be 2/3 either. 10. And then neg 3. Actually, y would be neg 1, I think. Negative 1. 10. Yeah, that's good. Because you get 2 times 2 is 4. And if you throw neg 1 into here, neg 3, neg 1 is plus 3. That's going to be 4 plus 3. Yep, okay. But anyway, and your ordered pair would be 2 comma neg 1. But if, anyway, that's it. But if things are out of order, you need to get them in order, right? If equations are out of order, you're out of luck. Even if you use advanced things later on, you can't work until you get things in order. You've got, even with and it gets even worse if the more variables you get. When we move from lines to planes, this will really haunt you. You want to get this guy here to be like this guy right here. Let's see, anything else I might have left off? I think I've covered the ground. That was a lot of ground. As far as number 18 goes, there are the following statement using lines. There are twice as many soccer fans as there are football fans. So there are twice as many soccer fans as there are football fans. And what they want out of number 18, guys, they want X is, you have a lot of soccer. You got to multiply football by 2 because you don't have a lot of football. Football is Y. You have to multiply football by 2 to get what you need, right? So you have to multiply football by 2 to get what you need. So X equals 2Y. Now, guys, technically it's X equals 2Y. But if X equals 2Y, you Benedict Arnold 2Y, and you get X minus 2Y equals 0. And so there's number 18. And then number 19, the number of new clients, X, is 177%. The number of old clients, X equals 1.77Y. You turn percent into 1.77. So X equals 1.77Y. But you subtract 1.77 over, and you get x minus 1.77 equals y. And what's going on there is like it's x x is 177% y. It's x equals 1.77 y. But you subtract that, you subtract over. You want general form. They're asking you for general form, okay? And they want the general form like that, okay? Anyway, so they want that. Let's see. Now, number 15 we've done already, so we're good through 15. Wow. We've done number 10. Yeah, we painfully have done number 9. Wow. Yeah, these get ugly, don't they? Yeah, and I've done number 16 in fraction mode. If you want to convert fraction to decimal, be my guest. It's fine. You just use decimal. 16, you just use decimals instead of fractions. Wait, no. 16 is different. We're doing a line, aren't we? Find the intersection of the line through those 2 points and the line through those 2 points. Oh, wow. Okay. So we want the intersection of a line passing through. Now, this is algebra 2. This isn't really... So we want a line passing through these 2 points and these 2 points. Okay. Well, let's see. Really, for this one, if I have time, we do algebra 2, 0, 1, and 4.62. So we need to get what we do on this one. Let me just skippity on down. I know what to do. It's just I'm used to. Wow, I wasn't even in the mind frame. I didn't know. Okay. So we get the slope. We do. Let me see if it'll copy this guy pretty nicely. Actually, let me do the whole thing. It'll let me. Control C. Yeah, there we go. That's okay. So we have now 01 4.62. So I need the slope, and the slope is going to be m equals, and I'd rather have lowercase, but it's okay. Now when I do perpendicular, I wouldn't like that. So I need slope equals, doesn't matter anyway. Let me just go to equation. M equals, now remember guys, you do y2 minus y1 over x2 minus x1. So you do y2, and where's my subscripts? So subscript, subscript, subscript. Well, you got to type it in the sub command. So you do y2 minus y1, and I got to do subscript command. Let me just copy y2, and then I can alter as I need to. Y2 minus y1, and I'm going to erase that, put y1 over x2. So that needs to now be good. Go down there. So x2, then minus x1. So that needs to be changed altogether to x1. So there's my slope. Now, so what I do with slope is I'm going to go this order. I'm going to subtract this way. So I'm going to do 2 minus 1. It doesn't really matter what order you go in, but the order once you pick an order, you got to stay in that way. And then 4.6 minus 0. Okay. And equals. Now, students sometimes hate me when I do the equality chain, but guys, I've been going down the paper for about 2 hours now, and this is a sloppy equality chain. You'll have to forgive me. And that's going to be 1 over 4.6. Now, if you multiply top and bottom by 10, if you do times 10 times 10, 1 times 10 over 4.6 times 10. That's going to equal, this would take a page for me to do it, like m equals this, then m equals this, and m equals this, a whole page of m, then m equals this, and m equals this. I'm just doing a big chain. So it's going to be 10 over 46. I've been doing chains the whole class, so you should be fine. So that's going to be 5 over 23. I finally have my slope, right? There's the slope. It's 5 when I reduced it. I reduced 10 over 46 to, what did I reduce it to? 5/23. Oh, man, I'm getting slow here. Okay, now, hey, we already have the y-intercept for free. It's 0, 1, so we don't have to go digging for it, thank goodness. So we know, so the first line is going to be, we can write it in slope-intercept, which is good. So it's going to be y equals 5, the slope is 5/23 x plus 1, because the y-intercept is positive 1. Now, the second line, they're not going to give it to me for free. I got to get the slope. So for the second line, my slope, I'll use big M. And it's going to be, now I'll go this way. I'll go right to left. Now 0 minus 3, and then I'm going to have 5.4 minus 1.9, and then so that's going to be negative 3 over 3.5. Ew. Okay, and that's going to be, now we can yank the negative out to the side. That's going to be 30 over 35 multiplied by 10 like we did earlier. I kind of skipped the step where I did the times 10 times 10 here. Yeah, y'all can forgive me. Now reduce by 5, divide by 5, and that's 6 over, well, put the negative, sorry, negative, and that's going to be 6 over 7. Wow, okay. So I get, so for my second line, I get y equals neg 6/7 x, but I don't have my y-intercept, do I? Oh boy. So I got to do point slope. Now I passed through 5, 4, comma 0, so I have my x-intercept. So what to do? I have my x-intercept. So I'm going to pick on 5, 4, comma 0. So what that means is, you remember y minus y1 equals, by another rule, y minus y naught, by point slope, y minus, well, shucks, I got to use subscripts again. Y minus y naught, or let me use y1 so you won't get confused, equals another slope. I'll just call it m. It's my same old m, right? It's my big M. X minus x1. Yeah. Why don't I pick on? Actually, why don't I pick on my 2? I'd rather pick on my same old y2 and x2. Y minus y2 is x minus x2. Well, shucks. So x2. So I got that. And holy Toledo. Now, who was y2? Y2 was 0. And m was neg 6/7. Ew. And it's not scrolling down real well. Okay, there we go. And x2 was 5.4, right? 5.4. Oh man. Now, so we get that. Now, guys, 5.4, that's 5 2/5, right? I need to get an improper fraction. 5 2/5, and that's going to be 27/5. So that's 27/5. Okay. Well, but hey, yeah, I don't have a whole lot longer. Now, but if I subtract 0, that doesn't amount to anything, right? Minus 0 doesn't really amount. So there's that. We got lucky. Now, usually we don't have 0 there. Okay. Now, Control V, so we have that. Now, if I distribute -6/7 through, well, it's going to be, how painful will it be? I don't know. Let's do it. Oh, wow. It's going to, so the x won't be painful at all. But now minus a negative is plus. Now, I don't see any cross canceling, guys. 6 and 5, no. 7 and 27, no. 7 times 5 is 35. This times this. And 6 times 27, 6 times 7 is what? 42. Carry the 4. 6 times 2 would have been 12, but 12 plus 4 is 16. Yeah, 162. Okay. This won't reduce because I couldn't cross cancel. There's no way it'll reduce. So there's that. If you can't cross cancel, it's not going to reduce later. So there's that. So this is my second line. That was my painful second line. Okay, so I have my painful second line. Wow. Okay. Now, guys, I think technology would be a lot better. So, but yeah. Yeah, that was kind of painful. To be honest with you, yeah, that hurt. But what you do now is set the right sides equal. And you're going to get, well, let me just put the characters on the ball field. You'll set this guy equal. I'm not going to pretend like I look forward to what this may come to. You'll set this equal to this, and oh well, yeah. And then you will, if I multiply, I guess I could get no. I want to get my x's on one side, so that doesn't appeal to me. What I was thinking. So you want to do Benedict Arnold. I need to copy this guy. Control C, please, and then Control V. And then, so with that, you always want the other line in view. So minus 5/23 x, but that's got to go now. Bad. That's got to go. And then what has to come on in is that negative 162 over 35, and it's negative because it jumped the river, and that plus sign has to go by that 1 because it didn't jump the river. So that plus 1, guys, it stays plus 1. Okay. Now, I don't know, guys. Yeah, I don't know if I like this. Yeah, I might leave it to y'all from here. Can y'all handle it from here? You'll need the least common multiple, or least common denominator for 7 and 23, and that's just going to have to. There's no kinship. It's just 7 times 23, and you'll need to turn 1 into 35 over 35. And neg 162 plus 35 positive is going to be slightly less negative, but still negative on the numerator. Your fraction that remains will still be negative, but not quite as negative. It'll still be pretty negative, but I don't know. Yeah, I may leave that one to y'all, but y'all get the idea. Just use a symbol lab. You can SYM use. I'm running out of time. You know, it's just irritating algebra. You could go across. You could hit 6 of 23. You could hit now so you get 35 there. 138 and 35. That's 173. I don't know if that's worth it. 173 over 161. And negative, so it'd be neg 173 over 161 or something. I don't know if that was worth it at all. If it's, I may have even messed up. I don't know. What did I even say? 23 times 6, 18. 6 times 3 is 18. That's 138. Yeah, neg 138 minus 35. That would be neg 173 over neg 173. So it's neg. So again, the fraction is neg 173 over 161. And then times x. Okay, neg 173 over 161. Now the x would, and that x would go on top, but I'm using the ugly editor. And then you'd get now neg 162 plus 35 is neg 137 over 35. That's not pretty at all, though. And but then you would get x would equal, now the neg, now it'd be, the two negs would kill each other, and you would get, the negatives die, you'd get 137 over 35, but then times, and then this other guy would Q switch, and it would be 161 over 173. And there's no way in tarnation that I can tell you who would cancel or what would cancel. I can tell you that 7 does go into, yeah, I can tell you, yeah, 35, 7 does go into 35, and 7 will go into 161. I can tell you that. So I can tell you that there will be a little bit of action on the 7. So if you use 7, but I'm assuming I've not made a mistake, and that's a bold assumption. 23, 7 goes into 35 5 times, but even now you're not out of the woods yet. That's still nasty. Yeah, that's still plenty nasty. 137 times 20 something, and then I don't even know. I don't know if that even looks right. 137 times 20 something, 173. That's going to be on the order of 8 or 9 or something, roundabout. Something ain't right. Something's not right. And guys, yeah, I'd like to find my error on this one. And I'm getting hungry, and I kind of got to go anyway. I got to. But let me see. Oops. Wow. Yeah. Let me come back to Word. It's around 3 point. They got 3.4. I don't see how. 137 and 173. That'd give you about decimal 8. No, I don't know. I don't know. There's hope. 137 times 23. What do we have? 137 times 23 over 173 times 5. What was even down there? 5. 3.64. I'm a little bit off. I must have messed up a little bit. Wait, was it 23? Yeah, I'm afraid so. Let me see. Um, well, yeah, guys, I've made a mistake somewhere, but I can't figure out for the life of me where. 18, and then 138, and these are both negative. They're going to reinforce, and that's 173 on the top. 173 over 35. Wait, 173 over 161. No. And then yeah, that's with the x, and that's neg. And then now I'm getting a positive x. Yeah, yeah, yeah. Find the intersection of the line. I'm getting 3.64, but now 5.4. Let me go back and just make sure. But anyway, you can use technology. You can use Symbolab. Go to Wolfram Alpha or Symbolab, SYMBOLAB.com. But anyway, I don't want you to use it as a crutch, but you can use it to check some of your answers. Okay, don't be unethical with it. That would have been. Well, guys, I just don't know. Huh. I'm trying to think here. 137 over 35. Now 7 goes into 35 5 times. 7 and goes into 21 3. 137 times 23 over 5 times 173. No, I'm afraid so. Well, that beats all. Let me see. Find intersection of lines. Symbolab. Let me see. I can't figure out what I did wrong. Well, this beats all. Solve equations, Symbolab. Well, now I'm getting grumpy, and I gotta go badly here in a minute. Oh, solve system of equations. I may have to go to Wolfram Alpha. Now I'm getting grumpy. Where was I? Guys, well, here it was. Let me see. I'm trying to think. Wait, neg 162 plus 35 would be neg 137, right? Over 35, right? And then minus 5 over 23. 23 times 6 is 138. Wait a minute. Wait, this is 138. 138. Wait a minute. 23 times 6 is 138. 138 and 35. It's 173. So let me copy this. I've got to go badly. I've got I didn't copy it. That's the pits. Neg 6/7 x plus 162 over 35. Let's see if I made a mistake a long time ago. 5.4, 5 and 2/5. That's 27/5. Let's see, my slopes look good. That's 2 minus 1, right. Yeah, that's going to be 10 over 46. That's 5/23 positive. And 5/23 x plus 1. That one's right. The second one would have been the one I would have goofed on. But it's neg 3 over 3.5. That's neg 30 over 35. That's neg 6/7. And then, right, yeah. And then 6 times 27, that's 162. And then 7 times 5. Yeah, that all looks right. So let me go to Wolfram Alpha, system of equations. And I'm going to have this video up real soon. Wolfram Alpha, I don't see what's wrong. System of equations. Neg 6/7 x plus 162 over 35. And then I don't need 4. And equation 2 is, well, I can't remember it. It was 5 over 23x plus 1. But actually, this was the first one, but it doesn't matter. Wolfram Alpha doesn't care. This was actually the first one. But Wolfram Alpha doesn't particularly care. Wait, system of 2. Sorry, it spat me out. I wanted to set these equal. System. No, I don't want a system of Wolfram Alpha intersection of lines. Not system of equations, guys. Sorry, intersection of lines. Oh man. Oh no. It's giving me such a hard time. 5 over y equals 5. Here it is. 5 over 23x plus 1. Man, that's taking me. It's just absolutely giving me a hard time. 5 and then plus 162 over 35. It's giving me a hard time like everything. Let's see if I can finally make this thing work. Oops. And I forget my y equals there. Okay, I have something. Okay. It says 2921 over 865. And 2921 over 865. So what is 2921 over 865? Oh, one moment, guys. Be right back. Okay, sorry. No, that's right. It's 3.37, but I can't figure out why. What did I do wrong? Let me come back. Well, I got to go in 7 minutes. I got 7 minutes to play with. So let me just stay calm. 2 minus 1. Right. Okay, there's my slope. And I got my that one. This line is right. The other line would have been the hard one. It's neg 3 over 3.5. So, and I used, now guys, I just picked a point. When you do point slope, you can pick either point. I picked 5.40, okay? And 5.4 is 5 2/5, which is 27 over 5, right? Yeah. 27 over 5. And here's my m right here. So I have that. And, but that's right. 2 negs make a pos. The 0 dies. I must have went wrong here. So my negs jived. And then, well, I'll be. I can't figure out where I went awry. So let me just scoot this down. Well, let me copy this guy. If I would at least like to see 23 times 6, 18, right? If I go across the diagonal, 23 times 6 is 18. I've got to multiply 23 here, 23 here. 23 times 6 is carry the 1, so that's 138. And then down here, 23 times 7 is 161. And likewise here, 161. Now 7 times 5 is 35. Now here, I turn 1 into 35 over 35. And then you just, now neg 162 in pods 35 is 137. Now this needs to go. All this stuff down here needs to go. So, well, I can't figure out what I'm doing wrong though. So I got Control V, and that's going to be neg 173. Yeah, I know it is. So this is going to make, they're 2 negs. They're going to make all the more negative. They're going to make a fierce negative. Neg 173. And then, and you keep the common denominator, right? And the negs cancel, right? So I get 173. Okay. Now 162 plus 35, I got to change that. That's going to be, now neg 162 plus 35, that is 137. No, it's 127. I see it, guys. It was 127 the whole time. Shucks. I'll be. So, ha ha ha. Well, I'll be. That can make a difference. It was 127. I can't believe it. And then I just do a Q switcher on the, I do Q switch flip. And then I'll do 161 over 173. And then I'm willing to bet, well, not $1 million, but I'm willing to wager that this will come out the right way. And, well, it'll come out the right way. So when I had it wrong a minute ago, what did I do? It'll come out the right way because now I've got my stuff. I had it's 127 times what is it? Well, I don't know. Again, I can divide by 7 and reduce the 5 like I did before. I can divide by 7 and cross cancel the 161 into 23. So 120, it's 127 times 23 and 5 times 173. So I can bring these together. So 127 times 23 and 5 times 173, like that. Let's see. I'm not going to bother getting the individuals. Let's just see what happens. 120. I got to go. 127 times 23 over 5 times 173. Yes, got it. And there, that's good. Guys, thank you. I got to go. Have a good evening. Bye-bye.